So today we're going to take equation solving one step further. We're going to put fractions and decimals in there. And oftentimes students want to just work with those fractions and decimals in the equation, but there's actually an easier way, which is to clear the fractions and decimals, and that's what we're going to talk about today. So here's an example of a very simple equation with a fraction in it. And most students would take a look at this and they would notice that you're dividing by 3. So the opposite of dividing by 3 would be to multiply both sides by 3. And then you've got another step here where now to undo the multiplying, you would have to divide by 2. You would get the correct answer and it would check. However, if we had just at the beginning multiplied by the reciprocal, because when you multiply a number by its reciprocal, it gives you 1. So if you were to multiply both sides left and right by the reciprocal, you would have gotten directly to that answer. The only thing about using the reciprocal is it has to be used only when there's only one term on each side of the equals, like this simple equation. So you just multiply by the 3/2 and you end up with that 1 in front of the x, do a little bit of cross canceling, and you get right directly to that x equals -18 solution that we saw a moment ago. So how about if you take a look at 1 and 2, pause the video, and try to solve both of these using the reciprocal. And I know I can because there's only one term on either side. Now be careful over here. That looks a little weird, but that could have been written 3/4 times x. It's just a different way of writing this, but with 3/4. And I just wanted you to see that in case you bump into it. So pause the video and solve these two. Come back in a second. We'll see how you did. Okay, so did you multiply both sides by 5/4? I got some cross canceling here. So the 16 and the 4 can cross cancel, and you should have gotten x equals 20. If you multiply, you just have to simplify at the end without cross canceling. Now I'm going to substitute the 20 back into 4/5 times 20. Remember that's 20/1. And I would end up getting my 16 equals 16. Again, you could cross cancel. There would be 1 5 here and 4 5s there, and this would be over 1. So again, remember that this guy is just basically this rewritten a different way. Multiply both sides by 4/3, the reciprocal. In this case, I can't cross cancel, and I end up with -112/3. Now I know up to this point in math, they always tell you to make this a mixed number, but I'm going to turn around. I'm going to substitute that in for x, and it can't be a mixed number to multiply. So I am A-okay that you leave this as the final answer as long as it's simplified. In other words, if you could divide by 3, you would want to do that, or some other number. So I'm going to put that in, and notice the 3's are going to cancel here, and I'm going to end up with -112 as the numerator. And when I divide -112 by 4, sure enough, I'm there. So one way to clear fractions is multiplying by the reciprocal, but it only works in that one sort of small case. So here's a different equation. You can see it's different from this one. So I'm asking you, why is it different? What's different? And what you should have noticed is that there's 2 terms on the right, no longer just 1 on each. So if you were to multiply by either reciprocal here, you will not clear the fractions. So we need to come up with a different way. But wouldn't it be great if we could get rid of those fractions? I mean, silly question. So the first thing I'm actually going to do, though, is show you sort of what students would have to do if they didn't clear the fractions. They would start by undoing this addition by subtracting 2/5. Now, when we come over here, you need to have a common denominator, and that's kind of what I'm doing over to the right here. So 4 would be 20/5, and 20 minus 2 would be 18/5. Now it looks like the one we just did a second ago. We're going to divide both sides by -1/3. Oh, by the way, multiplying by the reciprocal, which is what I'm kind of doing over here. And I end up with an answer of -54/5. Now, I say there's an easier way to do this. And oh, by the way, many students, when they leave the fractions in their equations, make a mistake somewhere. But when we clear them, the equation gets so much easier. So the way to clear the fractions when you have more than one term is to look for the common denominator. The least common denominator will keep the number smaller. To be honest, any common denominator will work to clear the fractions. So this 4 happens to be over 1. So you have a 1, a 3, and a 5. And you ask yourself, what is the smallest number that those numbers multiply into? And I'm hoping you're thinking 15. I call this the magic number. So the common denominator of all the terms in the equation is what you're going to use. And the way you're going to clear is you're going to multiply both sides of the equation, every term by that common denominator. And that's what I'll show you on the next slide. So this was the original equation. I'm going to multiply the left by the common denominator of 15 and the entire right by the common denominator of 15. And remember, if we multiply both sides of an equation by the same number, it stays in balance. 15 times 4 is 60. Now, when I multiply the 15, see, I'm putting it over 1 times the negative 1/3 y. I got a little bit of cross-canceling there. And I end up with a negative 5 over 1 y. And over here, the 15 over 1 times the 2/5. I got a little bit of cross-canceling there, 1 and 3, and I get 6 over 1. And guys, look at this equation. By multiplying every single term by the common denominator, I'm at a simple 2-step here. I'm going to subtract 6 from both sides, divide by negative 5, and yes, I do get a fraction answer, the same one we got doing it the kind of more difficult way, but it was a lot easier to get there. Now, the bad news is that when you go to do your check, you can't clear fractions out of the check, so you do have to kind of work with them. And I want to remind you, you can leave your answers as improper because to check them, they have to be. You can't multiply mixed numbers. So when I put the negative 54 over 5 in the original equation, there's some cross-canceling here. I end up with negative times a negative, positive 18 on the top, 1 times 5, 5 on the bottom. I add the numerators and the denominator is stuck, and 20 divided by 5 is 4. So I can clear the fractions out of the equation. I just can't do it out of the check. So I have a couple for you to try. So I'm going to ask you to pause the video and try this one. Now, guys, be careful. You only see one fraction, but reciprocal is not going to clear here because you have 2 terms. So I'm just going to give you a big hint. Common denominator. Pause the video, see how you do. Okay, so the first step here to clear the fractions would be to multiply the entire left by 4 and the entire right by 4. It's the only denominator, so it is the least common denominator, other than 1. A very common mistake is to not multiply the integers or the whole numbers by that common denominator. You have to multiply everybody. So 4 times 3, 4 times negative 3/4x, and 4 times negative 6. And when you do that, you'll get 12. 4's cancel here, leaving negative 3x equals negative 24. And oh my goodness, we have a 2-step equation. We're going to start by subtracting 12 from both sides. And now we have a 1-step equation. We're going to divide by negative 3, and we get x equals 12. We're going to substitute the 12 back in for the x there to check it. Now, this 12 is over 1, don't forget. So there is a little bit of cross-canceling, or you could just say 3 times 12, 36 divided by 4, which is 3 minus 9, and sure enough, it works. Okay, let's try one more fraction one here before I give you another example. Pause the video and try this one. Okay, again, you need to use the least common denominator, which in this case is 4. I'm going to multiply everybody by 4. This guy by 4, this guy by 4, and that guy by 4. Now, if we don't cross-cancel, you get 12 divided by 2, which is 6t. 4 times 3, you get negative 12 divided by 4, which is going to give you a negative 3t. And then multiply this by 4, you get 12 divided by 2, which is 6. This is a like term situation here. So 6t, take away 3t's. And then I divide by 3, and look, I'm already at my answer. Put the 2 back into the 2t spots here. I'm going to get 6 over 2, and then 6 over 4. Now he needs a common denominator of 4, so he would be 12 over 4. And 12 minus 6 would give you 6 over 4. And oh, by the way, that if you divided by 2, you will have an equals number on both sides. So that's clearing fractions. I'm going to show you one more example in an application, and then I am going to mention decimals in a moment. Okay, so this problem looks a little bit different, but do you see that common denominator? And there are 2 terms that are sharing it. So we want to multiply everybody by that common denominator of 4. That's where we're going to start. And when I multiply the left by 4, and please don't forget to multiply the right by 4, that's a common mistake. I'm going to have 4 over 1. These will actually cancel. So now I have 2x plus 6 equaling negative 44. And I'm right back to another 2-step. I mean, boy, this clearing fraction stuff is pretty cool. I'm going to subtract 6 from both sides, divide both sides by 2, and I've got x equals negative 25. To check it, I am going to put it back in the original, substituting, and now I just need to kind of do my order of operations. I'm going to clear this, or rather clean up the numerator. So I have a negative 50. We're going to multiply and then add 6, which will give me negative 44. Divide that by 4, and sure enough, I will get the negative 11. So that's just another example. If you split it over the common denominator, you would have 2x over 4 plus 6 over 4. I mean, so they're just sharing that denominator. Multiply both sides by that denominator, and you clear the fractions. So finally, here's an application problem that kind of deals with this. So let's say that you have 2 test scores. One is a 92 and one is 75. And let's say that's all you have for grades for your quarter, and you want to get an A-, and there's going to be a 3rd test. And you want to know what grade do you have to get that 3rd test. So what score do you need on your 3rd test to earn at least an A-? And I'm going to call that A- a 90 just to make things easier here rather than like an 89.5 or something, okay? So remember that this is a word problem, thus the 5 boxes, okay? So the first thing we're going to do is read our question, and that's going to be our unknown. So I'm going to define a variable, and you can pick anyone right now that's going to represent that next test, basically. So I'm going to let x be the next test score. Now, in order to find an average, don't you take the 92, the 75, and then there's going to be this 3rd score. You would add them together and divide by 3, right? So you would add all your scores up and divide by 3. So I'm going to write my equation. That's my 2nd step when I'm doing application problems. And then, of course, I'm hopefully going to equal a 90. This looks like kind of the one we just did. So if I want to clear the fractions, so my next step is to solve this, right? If I want to clear the fractions, I'm going to multiply by this common denominator. So I'm going to multiply the left by 3 and the right by 3. These 3's are going to cancel. 3 over 3 is 1 times anything, right? 1 won't affect this product. And over here, I've got 270. Oh, by the way, I can also add that 92 and 75 because they're like terms. So basically, I already have 167 points in the bank as I'm heading hopefully to 270 to get that 90 average. I'm going to subtract 167 from both sides, and x says 103. Well, the next step in solving a word problem is, did I do it right? So I'm going to put that 103 back up. I'm going to add those 3 numbers in the numerator, divide them by 3, and sure enough, that is the correct answer. So now, what's the answer to the question? What score do I need on the next test? I need 103%, and basically I'm doomed unless there's extra credit. So there's just an example of an application of clearing fractions in a word problem. So the last thing I'm going to do just for a couple minutes is to talk about the fact that you can clear decimals out of equations too. But to be perfectly honest, I hardly ever do it. I don't do it if I have a calculator. The only time I've ever really cleared decimals if I find myself somewhere having to work with an equation with decimals in it without a calculator. However, I always clear fractions. So I am going to show you the decimal, and in this section, we will talk about clearing them. But once we leave Unit 2, you won't hear me request that you clear decimals, but I always will request that you clear fractions. So here is our map. Just before we move on, notice we've put in this clear fractions and decimals. So let's take a look at a really fun equation here, right? So now where does the clearing fall into our map? So if you are a person that changes minuses to plus and negative, you want to do that right off the bat. And we're still going to do the distributive property next, even with the fraction in there, and then we'll clear fractions and decimals. And the reason I have you do the distributive property first rather than clear is sometimes people make the mistake of multiplying everything, including these guys, by the common denominator, and then they go and multiply with the distributive property, and it has the effect of a double dose here. So let's do it a different way. Let's first do the distributive property, and I did not change the minus on this one. This could be a plus negative if you like, but 5/3 times 2 over 1 would give us 10/3, and don't forget to multiply this times this, and negative times a negative is a positive. The 3's are going to cancel. This is over 1. Or 15 divided by 3 is 5, however you want to look at it. I'm now going to clear the fractions by multiplying everybody, 1, 2, 3, 4 terms by 3. And when I do that, I'm going to get 12x minus 10x, because the 3's cancel, plus 15 equals negative 33. And look, no more fractions. Next would be to combine like terms. And I'm at a two-step equation. I'm going to subtract 15 from both sides. And I'm going to divide by 2. And I believe that my solution is negative 24. I'm going to put that negative 24 back into both x spots. And now it's a giant PEMDAS problem. So I'm going to come in here and I'm going to multiply and then subtract, still in the parentheses. And now I'm going to multiply. So multiply here in the distributive, well, excuse me, I'm going to do the subtraction. Now I'm doing the multiplying. And this would give me a negative 96. And if I multiply a negative times a negative, it's a positive. And 5 times 51 divided by 3 is 85. Add these two together. And sure enough, I get negative 11. Holy cow, right? But that's how we work with multi-step equations that have fractions. Do the distributive property first and then clear the fractions. So like I said, there is a way to clear decimals. It is handy if you don't have a calculator. The problem is it makes the numbers big. So I'm going to do one and have you do one, and we'll do one more application problem when we're done. So notice that this is the tens place. Don't forget there is no ones place, once. There is hundreds here and there's hundreds. So you go across and you look for the biggest place. And in this case, it's hundreds. So 100 is your magic number here, like the common denominator was your magic number back a few slides ago when we were clearing fractions. So I'm going to multiply everybody on the left by the biggest place of decimals, which is 100. And I'm going to multiply the number on the right, everything on the right. When I multiply by 100, it moves the decimals 2 places to make the number bigger. One common mistake would be to put 5x here, but remember I got to move it around the 5 and add a 0 to multiply by 100. This will be 875, and this will be 1,325. So what you can see is we cleared the decimals, but we ended up with big numbers. And like I said, if I have a calculator, I don't find this helpful. I'm going to subtract 875 from both sides. Divide by 50, the zeros cancel. 45 divided by 5 is 9. And when I put the 9 back in for my check, again, I can't clear the decimals, so I'm working with them here. 9 times 5 is 45, 1 decimal place. Line up your decimals. You'll have 5. 7 plus 5 is 12. Hold the 1. 8 plus 4 is 12. Add the 1, and sure enough, it works. I am going to require you to clear fractions and decimals in this unit, but moving forward, it will really only be fractions for the rest of the year. So how about if you pause the video and try to clear the decimals and solve this one, please. Okay, so what was your magic number? One place here, two places here, and over here there aren't any. So two places would be 100. So again, we're going to multiply everybody by 100. We get 70 plus 235x equals, and don't forget to multiply him. That's a common mistake. I'm going to subtract 70. And then get negative 470, divide by 235. And surprise, surprise, it comes out to a nice number. X equals negative 2. I'm going to put it right back in there and substitute it for W. I'm going to multiply before I add. I had a few people in the last unit, going left to right here. Don't forget your order of operations. So you should be multiplying first. And then when I add, it's one of each. You're going to subtract, and it will be negative. And sure enough, it is negative 4. Okay, so let's just do one last problem today and call it a day. Let's say that Howard received an inheritance from his aunt. He invested 5% of the total inheritance in stocks, 40% of his money in a CD, and that is a certificate of deposit. It is not like an ancient musical device. If the amount invested was $1,350, how much was the entire inheritance? Now, I know I've got to talk about 5% and 40% and $1,350, but what is my unknown? The total inheritance. So I'm going to name a variable for that. And I'm going to call it X. What I'd like you to do right now is pause the video and write the equation for the X and the information in the problem. When you're set to check, come on back. Okay, so now I know that I'm going to put this money in and 5% of this money in something and 40% of this money in. So there's 3 things I'm doing that will add to the total. So 5% is 0.05 as a decimal, plus 40 would be 0.4. So I'm going to take 5% plus the 40%, and that has to equal the 1,350. 3 things going on here. So 50% of the total plus 40% of the total has to equal 1,350. Let's find out what our total is. So the first thing I'm going to do is my magic number here is these 2 places. So I'm going to multiply by 100, by 100, by 100. And man, is this going to get big. I'm going to add those 2 together. Divide both sides by 45. And if I kind of just ignored the zeros, I might be able to see that, is going to be a 3. 3 times 45 is 135, but I got to put those zeros back on. So the original inheritance was $3,000. $3,000 what? $3,000. I'm going to check that by putting it back into that equation. So 5% of the 3,000 was the money that went into my, I think it was savings, stocks. 40%, so whatever this money is, went into the certificate of deposit. And the total I invested was $1,350. So 5% of 3,000 is 150. 40% of 3,000 is 1,200. Add them together, and sure enough, they equal 1,350. So, what was the question here? Because there could be some different questions I could ask, but remember, it wants to know what was the original investment, and that was, the original inheritance, that was $3,000. But I could ask a question like, how much money did you put into stocks? 150. How much money did you put into the CD, the certificate of deposit? 1,200. So there are some different questions that I could ask, and that's why you always want to go back and just make sure that you answered the question that was asked. So today we've hopefully made your life a lot easier, though at first you're going to kind of resist. You're going to do an assignment and you're going to clear all your decimals and all your fractions so that you are working with easier numbers. I hope that you buy into this like everybody does every other year pretty soon to make your life a little easier. Have a great day.